Hey Logic 1, it's Mrs. Bunker. I'm sorry we can't be in class today. This is one of those lessons that I would love to be working on with you face to face. But in the meantime, we will do it this way. Before we get started though, please make sure you've done your facts practice for the day and that you've also done the mental math warm up at the top of lesson 92, including that problem solving problem. Okay, so right now we're going to talk about percent of change. And so far, we've talked about using a percent to describe part of a whole. So like 50% of 10 is 5. 20% of 100 is 20. Examples like that. But we can also use percent of change to represent an increase or a decrease. A real world example to this would be like adding sales tax to a purchase or marking down the price of an item for a sale. So that would be the representation of an increase and a decrease. So we can use the ratio boxes just like we've used for our part-whole problems. So when we make a table for a part, I'm gonna flip it over, part-whole. Hold on one second, I gotta widen my screen. Okay, I'm back. So when we make our table for a part-whole or a part of a whole problem, the bottom number down here in the percent is usually 100%. So we're gonna use the same concept that we have part whole, but instead of that, we're going to be using the original, the change in percentage, and then that new amount. So using the words original, change, and new on the left side of the ratio box. So let's go ahead. If the change is an increase, we are going to add it to the original amount. If it's a decrease, we're going to subtract it from its original amount so that we can get the new number down here. So let's go ahead and take a look at this right here. It says the country's population increased 15%. Well, that wasn't supposed to happen. 15% from 1980 to 1990. If the population in 1980 was 120,000, what was the population in 1990? Well, we know that it's increased 15%, so we know that it is going to be, we're going to be adding to that 120,000. All right, so we know we're adding to that 120,000. So if you come down here and you look at this filled in box, we know that originally 100% of the population in 1980 was 120. We know that it increased 15%, so we're going to be adding 15% to find the actual count of the residents who live in the town in 1990. So we know that it's going to be 115% to represent the new population. So we're going to write this then as a ratio of 100 over 115. The original over the new percentage is equal to the original count over the new count. And you're going to see that modeled right here. 100 is our original count, our original percent. We know it's increased to 115%. So we're going to set up that ratio. 120,000 was our original population. Our N is our new population. So when you go ahead and you multiply across, we know that 100 times N, we're going to cross multiply here, is 100 and N, or 100 N. We know that we're going to multiply 115 times 120 to get this lovely number, 13,800,000. Well, when we divide both sides by N, we get that our new population was 138,000 in 1990. So that represents a 15% increase from 120 to 138,000. And that change right here would be, what would that be? 18,000. That it grew 18,000 people in 10 years. All right, same concept, only we're going to do example 2, and it's going to be a decrease. The price was reduced 30%. If the sale price was $24.50, what was the original price? Well, originally, it's 100% represents the actual price. We don't know that right now. We do know that it was reduced 30%, so we're going to subtract 30%. We don't know what that change was in the actual change in price of the shirt, but we know that it's now 70%. We are paying 70% of $24.50 to find out what our actual count is. So let's go ahead and set up our ratio. 100 over 70, so represented here, is equal to the original cost over the new cost. We're going to do our cross multiplication. We're going to multiply 100 times $24.50. We're going to multiply 70 times r. We get this new algebraic equation. We're going to divide both sides by 70, and we're going to find out that the original price was $35. So again, to think about it is 100%. When we're paying full price, we're paying $34. When we're paying it on discount for 70%, we're paying $24.50. So let's go down to example 3. It says a merchant bought an item at wholesale for $20 and marked that price up 75% to sell the item at retail. What was the merchant's retail price for the item? All right, well, we know that when this guy bought it, for him, 100% of his costs was $20. He paid $20 wholesale for this item. Well, he's going to mark that up 75% so that really the customer is going to be paying 175% of the retail. So let's go ahead and set up our ratio. 100 over 175 is that first ratio is equal to $20 over the unknown new retail price. When you do your cross multiplication and you get your algebraic equation, you find out that the retail price was $35. So even though the business or the merchant bought it for 20 bucks, he marked it up 75%. You and I, when we go to buy this thing, we're paying $35 for it. All right, so guys, go ahead and do that lesson practice right now. Please draw out your boxes. Make sure that you're taking time to understand what these problems mean just in context, because it's easy to do the math and totally miss really what the question is asking us to do. So do your lesson practice, make sure you check it, and then do your mixed practice. All right, guys, hope you're doing well.